Okay, so now let's move on to the tangent equation, and we'll use the unit circle again to kind of help us with this. So where does the tangent equal 1? What angles give us 1 when we take the tangent of them? So tangent of theta is going to equal 1 when sine and cosine are the same, since sine divided by cosine is what gives us tangent. So that's going to happen right here. And then it happens again right here. But the way that we can actually write all of these angles, so the cool thing about tangent is, again, the period of the tangent function is just pi, not 2 pi. So we're only talking about this first part, and then it starts repeating itself. So when I do the tangent, it's actually a little bit easier, where we're just going to write that one answer plus pi k. And you can see that will still give us this 5 pi over 4, because if I let k equal 1, I'd get pi over 4 plus pi, get that common denominator, and that gives us 5 pi over 4. So that takes care of that second equation. So that's what I kind of love about tangent. So now if we're looking at this, so again, we're going to have to use a calculator to do this one because there is no exact 3. When you're solving these, so to get the theta by itself, we'll take the tan inverse of both sides to get that theta by itself, because that undoes that. All right, so when we get here, we end up getting in our calculator 1.25. And then again, we need to have that plus pi k. I have no idea why my pen just changed colors, but we'll go with it. So, so I need to find all of the angles that fall within this. I have no idea what 2 pi is, so let's, in the actual decimal format, so let's figure that out really fast. So that's going to be 0, obviously. 2 pi is going to be 2 times 3.14, so it's about 6.2 we're just going to go with for right now. So I'm going to find all the values up until I get to that value. So let's let k equal 1. So when I do that, you get theta equals 1.25 plus pi times 1, which is just plus pi. Plug that in, and you end up getting 4.39. Sweet, that falls within that range. So there's my second answer. So I've got 1.25 and 4.39. So now let's see if there's a third one. So if I let k equal 2, you get theta equals 1.25 plus pi times 2. Well, this is clearly going to be more than 2 pi. So at this point, we're done. So there's just 2 values that are in this domain that give us that. And then here, if we were doing this third one, which you can't really see that well now, and we were to generalize it, the answer to this third one is just going to be this piece. That's the general form, is what that is called. So in general, with trig equations, they may have infinite solutions. So with tangent, you find the angle and you add pi k to it, or 180 pi, or 180 degrees plus k. So for example, here again, when I'm solving for 1 is the tangent of theta going to equal -1, well, looking at that unit circle, so we know that the tangent equals +1 when we're dealing with pi over 4. So it's going to equal -1 in this quadrant, so pi minus pi over 4, which puts us at 3 pi over 4. And then again, we can do that plus pi k. So let's find all the values that are going to be within that. So 3 pi, so if k is 0, we get 3 pi over 4 plus pi times 0, which is 3 pi over 4. Sweet, that lands in that domain. If k is 1, we get theta equals 3 pi over 4 plus pi times 1, which is pi. Get that common denominator, and I get 7 pi over 4. But then, now when I do k equals 2, I get theta equals 3 pi over 4 plus 2 pi k, or 2 pi, not 2 pi k, which automatically gets me outside of this. So at this point, we're done. Those are your 2 solutions. And then here, notice the difference is I don't have a restricted domain like I did here. So this is just going to be writing that general answer. So 3 pi over 4 plus pi k.